We have seen that stripes can be produced by using coloured yarns on machines with a large number of feeders. Some machines are designed to achieve stripes in a different way. A striper mechanism is required which can introduce a new yarn of a different colour and take out the old one. You can see this happening at slow speed. Such systems are used on circular machines, both single and double needle beds. Common products are scarves and rugby shirts. Usually up to 4 colours of varying width stripes are possible. Patterns achieved by individual needle selection can be produced on machines with one bed of needles, often called single jersey, and on machines with 2 beds. When knitted on 2 beds on circular machines, usually a fine gauge with more than 14 needles per inch, the fabric is generally known as jacquard double jersey. Such machines have a dial and cylinder, but the needle tricks are arranged in rib gating. Only the needles in the cylinder are selected, and this produces the pattern on the front. Unlike single jersey, where yarns have to float at the back of the fabric when not being knitted, in double jersey the needles are able to knit the yarn at the back when it is not wanted at the front. This produces a firmer fabric and avoids the problem of snagging float stitches. Perhaps the effect is easy to see on this coarse fabric, shown here at the front and here at the back. 4 colour jacquards are produced, but 3 colour jacquards, as shown in the next 2 examples, are the more common. There is a subdivision of double jersey fabrics called blister, relief or cloquet fabrics. In this instance, the 2 needle beds knit separate plain fabrics to a predetermined pattern, often with more courses being knitted on the front relative to the back. This produces an exaggerated pouch or blister effect. The size of the pattern is determined by the capacity of the patterning system. The older mechanical systems had small pattern areas. The modern systems, using computer-aided design and microelectronics for needle selection, has increased the possible size of patterning enormously. Another example of the application of computer control and microelectronics is the glove machine. A complete glove is produced requiring only a simple sewing operation on the cuff. Now we return to something already seen in the first video, namely the difference between a plain and pearl loop. To produce a pearl loop, 2 needle beds are required, either circular, as in the double cylinder half hose and the pearl machines we've seen so far, or flat. In both cases the tricks are as interlock gating, but the key point is the use of a double-headed latch needle. In this way, a needle can be in one needle bed, knitting the plain stitch, and then be moved into the other bed. The loop will move to the other end of the needle, and when the next loop is knitted, it will be a pearl stitch. Here is a flat pearl machine being used to knit a cricket sweater with the typical cable pattern. Note how, during the knitting where the cable effect is being produced, the whole of one knitting bed moves relative to the other. This is a common facility on flat machines and is called racking or shogging. As with plain knitting, tucking is also possible on rib machines. Particular sequences of knit and tuck have special names. For example, a half cardigan structure is one where tucking occurs on alternate courses on one needle bed only. The front and back look different. On the other hand, full cardigan structure tucks on both beds at alternate courses. The front and back of this fabric look the same. Another effect is also possible on certain V-bed flat knitting machines. This is called intarsia knitting, producing vertical stripes such as these. You can see that on unroving a course, the two yarns cross over a small amount to form a coherent fabric. This is the modern descendant of the 17th century design stocking frame we saw in the first video, and is called a Cotton's Patent fully fashioned knitting frame after the designer and builder William Cotton. As in the old style machine, the modern machine uses a spring-bearded needle to form the loops. The latch needle we have already seen is self-closing. Whereas the bearded needle requires an additional mechanism called the presser bar to close the spring beard so the old loop can slide over the top of the needle to form a new one. Cotton's Patent machine produces a single jersey plain stitch since there is only one needle bed. The term fully fashioned means that the width of the knitting, that is the number of needles in action, can be changed whilst knitting. This is achieved by transfer points seen here in action. The gauge of these machines is defined as the number of needles per 1.5 inch of needle bed. That is, a 15 gauge machine is equivalent to 10 needles per inch. On some fully fashioned machines, tucking, lace patterning and intarsia work is possible. Here we see an example of a sleeve blank from the fully fashioned machine, showing the shaping. A close-up details the fashioning marks. Note that the transferring is 3 or 4 loops in from the edge. This shows a completed fully fashioned garment and the typical fashioning marks. We have already hinted that new technology is replacing the old mechanical systems on knitting machines, such as the steels on the V-bed machines for pattern programming and the chain on the RTR for machine programming. Computer systems have been produced which are able to speed up the process of machine and pattern programming and also greatly reduce costs. For further technical detailed information, we refer you to the Open Text series of programs from Hinckley College of Further Education. This concludes the second video in the fabric formation set. Basic structures, garments and machines have been shown. It is likely that a second or third viewing of both videos will be helpful to fully digest the information.